Welcome back. This is the fourth part of a series of presentations about how to make object cases for kaleidoscopes. The first segment was an overview. The second was a video on making acrylic object cases. The third was a video on making glass object cases. And now in the fourth, the question is what to put in these cases. We'll get into a variety of more technical perspectives of first the materials that are commonly included inside, the liquid vehicles, as well as the inclusions. In regard to the liquid materials included, the first slide indicates three categories of substances, each with their coefficient of thermal expansion. Now, this seems to be a bit technical, but there's a number of applications to this. In the blue, indicates primarily the glass coefficients of expansion, and for those kaleidoscope makers that do hot work and mix different types of glass, they have to pay close attention to the coefficient of expansion. If glasses are mixed with a markedly different coefficient, then they're much more subject to breaking and failing at a future date, sometimes immediately after making whatever object that the artist is attempting to put together. Window glass or float glass is usually about 107. Then many companies are making fusible glasses that are described as being System 96 or System 90, with their respective coefficients being that. Borosilicate glass is down in the 30 range, and this is also known as Pyrex. Pyrex is frequently used in situations where there's rapid heating and cooling of the glass material, such as in cooking. However, for our purposes, glass tubing, when it is being sawed, may have a higher temperature secondary to the friction of the saw blade on one part of the glass, whereas the remainder of the glass is much cooler, and therefore inducing stress to the material and inducing cracks or breakage. So something that does not move very much from one part of the material to another, like Pyrex, is a better choice to use for that type of situation. So Pyrex is a better choice for most of our applications when there is a machining process being involved, period. Rather than the other types of glasses that it is a bit stronger and also melts at a higher temperature. The red bars represent the acrylic materials that are used. standard acrylic and plexiglass. You can see that their coefficients of expansion are substantially higher than any of the other materials. So therefore, you would not directly try to mix one to the others, put glass to acrylic, etc., because the glue joints would likely fail over time. Likewise, the green bars represent the metal substances, aluminum, brass, copper, etc., and they have medium range coefficients of expansion. So the fastening of these materials usually are best accomplished by techniques other than glues and adhesives. The original kaleidoscopes back in the 1800s used only a dry object case or cell containing only air and not putting in any liquid media. So now that there are other substances available and materials available, why do we include liquids? And there may be several reasons. One of which is to minimize the clicky sound. Some people don't appreciate the clicky-clacky noises that are made. But perhaps more importantly, abrasion, because the materials in the object cases, as they're being turned and moved, can, by friction, erode one another. But also there's a appreciation of the quality of the motion of the materials as they move in the mandala. By adding liquid, that slows the motion down, makes the change of image less abrupt and surprising, perhaps, and makes it more of a relaxing experience, period. Water could be used, however, is not frequently utilized. In one consideration, it's that it is a media by which bacteria and fungi can grow and can become cloudy over a period of time. There's also the issue of the pH and oxygen content that may oxidize or rust the materials in the case. And so people often use other materials. Glycerin is a highly viscous material, so it slows down the motion significantly. The other name for glycerin is glycerol, which the OL ending indicates an alcohol. Many alcohols are azeotropes. That means that the material absorbs water out of the atmosphere and dilutes the material itself. That's why it's very difficult for ethanol to get to a 200 proof concentration. It usually will absorb water out of the atmosphere and be around 97% alcohol. Methanol is not azeotropic. Isopropyl is, and so the cheapest grade of isopropyl alcohol is usually around 70%. It requires additional manufacturing manipulation to get it up into the 90 plus range. So there's a slightly increased cost to that. Methanol happens not to be azeotropic. However, glycerol is very much so, and so that's why it was mentioned earlier not to use that in acrylic object cases. It tends to absorb water through the plastic material, diluting itself but increasing the volume and then increasing the pressure within the object case, causing failure over a period of time. Glycerol is usable, however, in a glass object case because with the UV glue used to close the container, it makes it a hermetic environment and water cannot get inside. Other materials that are found in object cases are the oils. Mineral oil is something that's readily available, relatively inexpensive, can be obtained in most pharmacies, is optically clear. Because it is an oil, it prevents the oxidation of metallic materials. So if you include an item that is ferrous or iron based in the object case, it will not rust. In similar considerations, silicone oil is often used in industrial settings. It has a higher stability at higher temperatures. Also is an excellent lubricant. Is optically clear. Inhibits rust. But it's significantly more expensive. You can get silicone oil in a variety of different viscosities. Commonly, these are measured in a unit called centistokes. The higher the number, the higher the viscosity, or therefore the thicker the material, and therefore that slows down the motion of the materials or inclusions in the object case. This, I apologize, is a complicated slide comparing the characteristics of the suspending media. In the bright blue, that delineates the refractive index. So air is the first item on the list, and that is commonly the reference point for many of these measurements. Water is included for completeness sake. Then mineral oil and silicone oil are noted. Then glycerin, ethanol, and a variety of the other substances. The refractive index will be discussed more on the next slide, which is much more understandable. The red dots indicate the viscosity. So as you can see, the viscosities are all very similar, excepting with glycerin, which has a much higher viscosity number or thickness, and for curiosity's sake, I included corn syrup, which often isn't used because it has yellow discoloration, but that is also very high in its quality and available cheaply compared to the other materials. Density is noted in the green, and this may be relevant when you include pieces of differing base material in the object case. Or to put it another way, something that's mineral-based, sand, rocks, gems, may be very dense metals and fall to the bottom of the case readily, whereas it's something that may be plastic or botanical, may be lighter in weight and tend to float. So how the material moves is not only dependent upon the suspending media, but also upon its inherent density. Water solubility is also relevant, since air, water, and oils do not customarily mix. And so you could feasibly mix all three of those material in an object case, and so the juncture between those can give its own optical qualities or characteristics. A word about including air in the object cases. The Holy Grail might be to remove all the air and have a completely fluid-filled object case. However, we advise against that, since temperature and ambient conditions on the outside of the case do have influence about what happens inside. Including about 10% of the volume of the object case as air is often recommended. When the barometric pressure, the air pressure outside the case, increases or decreases, then the air acts as a buffer and can be compressed and absorbed the differences in pressure. Many times one must consider shipping, since if a kaleidoscope is shipped by ground, everything's pretty much at the same barometric pressure. But if it's air shipped, it goes up into an airplane hold where there's only half an atmosphere pressure inside the airplane. So that puts stresses and strains on a enclosed container. Next slide indicates suspending media refractive index. And they might appear to be relatively similar, however, small differences in the refractive index may have significant consequences. So if an inclusion is placed in a media with a similar refractive index, it may not be appreciated or seen when looking through the kaleidoscope. That can be a disadvantage if the inclusion is an expensive gem or crystal or some such thing, since it's an expense that is unnecessary. However, the opposite may be an advantage, where you can use glass stringers in a media and not have them readily evident. So the attention would be directed toward small objects such as seed beads, glitter, sand, small items, and change the characteristics of how those fall under the influence of gravity within a suspending media. The next slide indicates surface tensions, and the surface tension kind of holds the suspending media together. So where the inclusions may be of sufficient size, mass, weight, density, the mixture may not be held together very well, similar to what happens in an air-filled cell, so that there may be abrupt changes of motion that are kind of little surprises and may or may not be desirable to the artist. Other random considerations are first costs. The different materials to make the case vary significantly in their price. So acrylic extruded tubing is perhaps the cheapest, whereas the cast material is next in line, and then borosilicate glass materials are up there in the more expensive range as well, period. Solvent characteristics of the suspending material need to be considered as well. So sometimes there are inclusions that have paints, coatings, etc., that will tend to dissolve in some media and not in the other. Also, you need to consider whether the material to glue the pieces of the object case together would be dissolved or softened by what you're putting inside. Miscibility it was addressed earlier, whereas the air, water, and oil do not necessarily mix, which can be an advantage in creating more reflective surfaces, or having the object materials float in one level and not in the others. Another example of this immiscibility is using pigments or coloring agents, such as in a lava lamp. So that is another tool to consider. Colorants are usually water-soluble, such as food coloring. That's not advised because they will change color over time, and they're not UV protected. So the materials like alcohol inks, etc., would be desirable in that situation, or they would be lipid or oil soluble. And there are food colorings that are available that will be usable in a oil-based media. The hygroscopic character of the suspending media was discussed slightly before, whereas glycerol tends to absorb water out of the atmosphere, so that has to be accounted for. The viscosity or the thickness of the material determines how quickly the image changes, how smoothly the image changes in the object chamber and kaleidoscope. Another consideration is to burp or not to burp an object chamber. Now, what does that mean? Well, to describe the process of gluing the final face or side to the ring of an object case, usually a glue or solvent or cement is applied to the edge of the ring, and that is proud of the ring itself, meaning it extends above. So placing a flat piece of glass or acrylic on top of that and then allowing it to settle onto the edge of the ring creates a situation where inside the object case there's a slight increase in pressure. So some artists burp the cells, which is a process by which you slowly slide the face of the object cell away from the edge and allow that pressure to be relieved. Often there's a little pop. That's why it's referred to as a burp. And then slide the face piece of glass or acrylic back into position where it's then allowed to cure or be cured by ultraviolet light application. I've had extensive discussions with a senior artist who used extruded acrylic cases and always burped his object cases, indicating that he never really had any problems but felt confident that relieving that extra pressure helped minimize the tendency to leaks. So the controversy still remains, perhaps. Another question is how much to fill. The general recommendation is to never completely fill an object case. As mentioned previously, a small amount of air will allow for outside pressure differences and minimize the stress on the walls of the object chamber. During one of our meetings, an experienced kaleidoscope artist indicated that he only filled the object case halfway with the suspending media and never had a leak. Sometimes the suspending media, just simply wetting the contents of the object case, gives another different reflective, refractive character and enhances the visual experience. Other considerations might be a bit more subtle. It was mentioned earlier that by using water or like corn syrup, those are materials that may foster the growth of bacteria, molds, etc., and over time destroy the optical clarity of the suspending media. Optical clarity is usually assumed as being the holy grail of the suspending media and the content of the object cases. However, it is conceivable that the artist may want a little softer appearance to the images and intentionally put something in the suspending media to achieve that end. such as suspend mica powders that may cause a little shimmery effect, or Steve Spangler's pearl swirl material. So the next issue is that of specific gravity, whereas most of the objects in an object case will be submitted to gravity and go downward. The heavier, more dense materials will go fastest. However, sometimes the objects will have a significant amount of air or be inherently less dense, like some plastics, etc., and have a tendency to float or just be suspended in the visual field. The index of refraction has been discussed previously and can be used by the artist intentionally to make some things disappear and draw the attention to small materials such as seed beads, glitter, etc., and create a different visual effect. Failure of an object case is always a concern and usually translates into a problem with leakage of the contained material. Randy Knapp gave some advice to me one time, and he said that when you're making something, keep in mind how to fix it, and sometimes you gain a better understanding of the object when you try to break it. One recommendation initially is in making an object case is to be extremely careful, meticulous, intentional, obsessive compulsive, if you will, about assembling the pieces together and the process by which to do that. One thing I've learned to appreciate over time in dealing with epoxies is that the enemy of epoxy is oil or grease, and whether it's silicone or mineral oil or just simply oils from the skin, perspiration, that many times will inhibit excellent bonding, particularly with the UV resins. So I therefore will often use gloves, not just to protect my skin, but also not to leave behind the fingerprints or oils from the skin. Preparing the surfaces very carefully with alcohols to remove any grease or oil is quite important. Sometimes I will use the approach of doing duplicates when a process is very complex or extended, so that if there's a major mistake, you don't have to start from the beginning. You just rely on the second copy and restart the process from where you left off. Another approach is to make it replaceable. Some of the kaleidoscopes are designed intentionally so that the object cases can be replaced easily and are not inherent or permanently affixed to the main body of the kaleidoscope. There's a question about, will the leaks stop? As indicated previously, there's a concern about pressure differentials in transporting the kaleidoscopes via air freight. Sometimes the kaleidoscopes are made at sea level, but sold to a client that may be up high in the mountains at an elevation of 7,000 feet. Sometimes there's a significant amount of vibration or shaking in the transportation or delivery of the kaleidoscopes. So, Mary Wills at Nellie Bly has indicated that quite often, it's 3 out of 4 times, the leaks may stop on their own. So giving it enough time and period of observation is valuable. Many times when I make a object case, I will do so before I make the kaleidoscope and put it on the shelf for a period of time, even months, just to attain a reassurance that the seals are firm. Another approach is sometimes to stress test it. One of the kaleidoscope artists indicated that sometimes they put it outside so that there's different exposure to light, heat, temperature, etc., even within a couple days out on the back porch. That gives additional reassurance that your seals are intact and the product is of good quality. Sometimes it's a matter that unfortunate things happen, and don't take it personally. Just start over again, reassess your process, and redouble your care with which you're putting the materials together. The next issue is that of the solid contents or other inclusions in the object case. Actually, this is where the design becomes the most fun. There's no right or wrong. Many times, again, I look at the choice of things in the object case as being your palette and your brush and your media by which you're doing painting and trying to achieve a mood. Make a statement, reflect or complement what's on the outside of the body of the kaleidoscope. The previous considerations and discussions have all been made with the intent of helping make the choices more deliberate and to achieve better success without being so random about it. It is your opportunity to paint the image, complete a theme, and to achieve a better result. It's many times very helpful to include the dry chamber, put your inclusions in the chamber and put a temporary cover over it and use a separate utility mirror system, perhaps not the one that you would put into the kaleidoscope in final construction, but to have one available at your bench top in order to monitor the effects of your artistic process. Rotate the object case in front of that mirror system and study the colors, the composition, the character of the mandala. Inclusions can be many, many things. Frequently glass, shards, pieces, frit, beads, glass rods. When you're making a choice about glass, if the light source is coming through the end of the kaleidoscope and not from the sides, then translucent or transparent glass, like cathedral, colored glass is perhaps a better choice than opalescent, which tends to be opaque. Opalescent works better with the light coming in from the sides or from the front, from where the observer is situated. Stringers, millefiori, glass ampules were very popular with the Bush scopes, but have a lot of technical challenges in the making of them, so it may not always be a practical inclusion. Many times we'll take glass that's scrapped from other work projects and lamp work it into swirls, stringers, agglomerations, just to have fun and to manipulate the glass into interesting shapes to be included in the object case. Texture is an interesting issue and a little challenge to achieve with lamp working, but you can twist it, swirl it, mix two different glasses together to achieve a whole different effect. Plastic is difficult to lamp work, but because many of the plastics that we are using are thermosensitive, you can manipulate them with the addition of gentle heat to achieve different shapes, stretch it out, twist it, etc. Now with the advent of 3D printing, the filaments are much more controllable. In fact, there are independent pens that are used to sculpt or design your three-dimensional objects with the 3D filaments. And there's many varieties of color and textures to those as well. Epoxy is something that can be your friend in this regard, particularly with botanicals. So flowers, seeds, etc. are usually softer than other elements included in the object case and are more subject to abrasion, falling apart, disintegration over time. But with a small amount of 2-part epoxy, they can be dipped in that and let harden, or more relevant these days with the advent of UV cured epoxy resins, you can just simply dip it in, submit it to a UV light, and you have a encased, hardened, protected, preserved botanicals object. Other things such as photographs or things on paper may be preserved in a similar fashion. Fabrics, lace could be preserved and hardened with the UV resins and give a different texture or character to what's included in the object case. Barb Mitchell, I believe in the 80s, developed what she called was the spectrosphere. And this is a 2.5, 3 feet diameter acrylic hemisphere that had a frosted surface to it. And a person would sit in a chair with their head in the hollow part, concave part of this hemisphere, and images from a kaleidoscope would be projected onto the frosted surface. It's kind of a portable mini IMAX theater, so you could be immersed in the kaleidoscopic image. In order to project the image onto the atmosphere, she used a standard slide projector. And so her object cases had to be of such nature to fit into the slide projector and be survive the high temperatures from the bright light. So her object cases were perhaps at most a 1/4 inch in thickness. They had a little groove around the perimeter, the outside, where a drive belt could continually rotate the object case. And she included small, fine glass objects, in some cases, liquids that were colored with different dyes. And she had some that included actual slide photographs of the space project Apollo missions for others. So there's a wide variety of size and shapes and applications for the different object cases. We've already referred in part to the botanicals and encasing them in epoxy resins, whether it be 2-part or UV. Minwax has a product that is called wood hardener, and that's another option. There's another type of product called cactus juice that wood turners often use for hardening soft wood, such as spalted wood or balsa wood. The color fastness is another consideration as to what light sources may be exposing the contents of an object case. So UV resistance may be a quality that you want to look for in using coloring agents, dyes, paints, etc. The issue of oxidation is also there, since some of the metals may form a patina, such as copper or brass. The rust coloration of iron-containing inclusions are also a concern. And sometimes the pH of the suspending media are relevant in those situations as well. Speaking of ultraviolet, that is a light source that can be used to induce fluorescence in the inclusions in an object case. So that may be a desirable thing to give different visual effects. Styrene plastic in particular, and certain types of tapes like Scotch tape, tend to have a feature where, when placed in polarized light, will give a rainbow effect and give different patterns of color. That's not often a shared feature with the other plastic forms, but styrene plastic is frequently used to create picnic knives, forks, and spoons that are clear, as well as the so-called jewel cases to protect CDs and DVDs. The inclusions include many different things and may be made of metals. We've already discussed the fact that oxidation and patinas are a consideration. However, the sharpness of the edges of the metals, just like with the sharpness of the edge of glass pieces, can enhance the erosion with constant turning of the materials in the object case. So metals can be of many different forms to achieve different colors. Heat and torch work on metals can also achieve the different coloring oxidation patterns similar to the different colors under UV light with styrene plastic. Sometimes I have saved the drilling products when I'm drilling a soft metal and the spiral forms come out of the drill. They can be interesting inclusions. Now, motion is a critical aspect to the image production in a kaleidoscope. So how you agitate or how you cause motion with the inclusions within the object case is another issue that may need some consideration. Some kaleidoscope artists will intentionally glue a piece of material on the inside of the object case so it's affixed to the case and therefore stirs or mixes the other loose ingredients to always cause a variety of appearances in the mandala. Sometimes different type of stringers, clear glass rods can be included. They are many times more effective if they are about 2/3 to 3/4 of the transverse diameter of the object case. They can vary and not necessarily be straight rods. They can be worked in a torch to be curled and textured. Magnets are a way of mixing the materials in an object case. Sometimes you can place an object or a magnet inside the object case and use a magnet on the outside to manipulate that. Sometimes you can use several types of torch-worked clear rods and glue them together with UV glue to have kind of a scaffolding. So when the object case is rotated, the smaller objects such as seed beads and glitter, etc., fall through this scaffolding in interesting motion effects. Part of the question is how much do you put in the object case or percentage of fill? Usual recommendation is about 60% of the total expanse. In art, there's a concept of negative space. So it's not only what is filled with a colorful or interesting textured object, but sometimes you need open space to provide a contrast to more perfectly appreciate the image. So not jam-packing the object case full of beads or materials will allow for better motion, and it also allows for the mandala to be better developed. Now, in how a person handles the kaleidoscope, that changes as well, because if there's, say, only 50% of the visual field filled with materials and they gravitate downward, then that causes an image to be more central to the vertex of the two mirrors. And there may be a lot of open space up at the wide area between the mirrors. However, by changing the angle at which a person is viewing the kaleidoscope, putting it down, or even better, at a high angle upwards, then the inclusions will distribute themselves among the front or back surface and fill the field of view. So it gives a better control on the part of the viewer as to what type of image they can have, and a better variety of mandala with the same object case. Size of the pieces is a consideration, and when you're testing the object cases and filling it with your work mirror system, you can study the effect of large items such as marbles, or the very small items like sand, seed beads, glitter, etc. 3D objects may include trinkets, animals, gears for punk type of presentations, symbols that may all be theme related. Many times these are opaque materials that are best viewed with side lighting. But here again, with using a work mirror system and studying what the effect of adding these objects to an object case before the kaleidoscope is assembled may help you get a better effect. With materials such as glitter, sparkles, frit, other things that are being included for reflective purposes, sometimes those things will tend to clump together and behave differently when in a suspended media rather than in an air-filled cell as you're preparing to enclose the object case. So sometimes taking a little bit of the suspending media and then putting, say, the glitter in there, shaking it around and studying what its behavior is will avoid some disappointments when making an actual object case. Filters and polarizers, sometimes holographic films, etc., can be used inside or outside the object cases to achieve star-like effects or different coloring effects. Sometimes these can be borrowed from photography equipment and give a pleasing visual endpoint. When using all these considerations, it comes back to painting the image or painting the design. And so the design principles or elements are frequently referred to as line, shape, color, texture, and use of space, positive and negative space. So keeping these in mind as you're assembling or putting materials into the object case will help perhaps alter the visual effect that you have with your kaleidoscope. Sometimes you are wanting to create a theme or a mood. Sometimes you can achieve that by doing certain colors or having a color scheme, if you will. Sometimes those are homogeneous color schemes. Sometimes those are complementary or split complementary. Sometimes you can create a message by including certain materials. One example is that I printed out a variety of musical notes and symbols, a G clef, F clef, etc., to be included in the kaleidoscope that was predominantly in a blue color scheme, and the entitled name to the scope was Rhapsody in Blue, as one example. Other design elements are balance, symmetry, movement, rhythm, proportion, contrast, emphasis, harmony, discord, the positive and negative space considerations and themes. Just a few remarks to emphasize the fact that you don't have to fill the object case to the brim with inclusions. Again, 60% filling allows more opportunity for movement and the development of geometric or floral designs. And again, the scope may be held in different positions so that the inclusions are distributed in the kaleidoscope differently and give more control to the viewer. Samuel Taylor Coleridge was quoted as defining beauty as the unity of disparate parts. I find this a very interesting definition, and I'll leave you to ponder that. With the kaleidoscope, I think the reason it is such an attractive instrument is that it creates a device that is a participatory art form, so that the observer has to do some of the work in manipulating or turning or changing the angle to the scope, but the mirrors help quickly make a coherent pattern or mandala from all of these different little pieces that don't necessarily have a relationship to one another. This concludes most of the comments on the making of kaleidoscope object cases. However, there is an additional segment of video which gives images in about 20-second bits of object cases with different materials. Some of these may be marbles, some of them may be stringers that are only straight objects. Some have object cases have different percentages of fill of materials. Some of them have different amounts of fill of the suspending media. There are 6 particular images whereas the first is air-filled or a dry case. Second is mineral oil with less than 50% fill. Third is mineral oil with perhaps 60-70% fill. Then there's silicon oil with 500 centistoke viscosity. Then silicon oil with 1,000 centistoke viscosity. And lastly was glycerin for an appreciation of how the materials move. The film was taken on a device turning the object case at about 1 to 2 revolutions per minute. All the object cases were on the same device, so the speed is the same for each movie. And also, when the object cases were filled, the same inclusions were put in all 6 object cases, so that there should be fewer variables and a better side-by-side comparison. There is a segment of the video that has all 6 mandalas from those different object cases next to each other in one panel. So that way you can make a side-by-side comparison to see if the visual effect of one material and fill amount achieves your goals in making your next kaleidoscope. I hope all these comparisons, comments, reflections, little pearls from senior members of our group are helpful to you, and I hope you continue to enjoy making kaleidoscopes in the future. Thank you very much.